Astronomers have recently observed a fascinating and mysterious event in the cosmos. Far away, approximately 11,000 light-years from Earth, lies a star named Gaia 20 Ek. This sun-like star, until recently, seemed perfectly stable. Its brightness followed the typical predictable patterns seen in many main sequence stars. But things began to change around 2016, when astronomers noticed something odd. The star's brightness started fluctuating in a way that didn't match the usual stellar activity we're accustomed to seeing. At first, the dips in brightness seemed minor, but as time went on, the irregularity grew. The dips were not consistent, and their timing didn't follow the regular pattern you'd expect from a planet passing in front of the star. This was unusual. Planets, when they transit across their stars, typically cause a steady, repeating, dimming effect. But Gaia 20 Ek's behavior wasn't following that pattern. Some dimming events were deeper than others, while some were very shallow. This chaotic behavior led astronomers to rule out the idea of a single planet, or even multiple planets, being the cause. The star's light curve, which tracks the star's brightness over time, began to show sudden, unpredictable dips by 2021. These fluctuations were larger and much more irregular than before. Rather than an object moving in front of the star, the fluctuations hinted that a cloud of material, rather than solid bodies like planets, was passing in front of it. The material wasn't just passing in front of Gaia 20 Ek randomly. It appeared to be something new, something hot, freshly formed, and dynamic. The breakthrough came when scientists analyzed the star's data across different wavelengths. While visible light showed the star's brightness decreasing, the infrared measurements revealed something startling. The material surrounding the star was warm, indicating that it had recently been heated by an energetic event. This suggested that the fluctuations were not due to planets, but rather a massive collision of planetary bodies that had created a hot, debris-filled cloud orbiting the star. As the investigation into Gaia 20 Ek continued, researchers pieced together a compelling story of planetary evolution. The most likely explanation for these extraordinary brightness variations is a collision between two young planets. It's a process that likely began with minor, grazing encounters between the two bodies. These early interactions would have released small amounts of material into space, but the situation escalated when a larger impact occurred, sending debris flying outward in all directions. This debris cloud is now orbiting Gaia 20 Ek, and it occasionally blocks the star's light, causing the observed fluctuations in brightness. The size and irregular shape of the cloud are important clues. It orbits the star at a distance roughly equivalent to the Earth's distance from the Sun, about 1 astronomical unit away. This places it within the zone where rocky planets typically form, making it an incredibly rare opportunity to study the early stages of planetary formation in real time. But that's not all. The location of this debris is also significant because it gives scientists a chance to study a key process that has shaped many planetary systems or planetary collisions. For example, the most widely accepted explanation for the formation of Earth's moon involves a giant impact between the young Earth and a planetary body roughly the size of Mars. The debris from this collision formed a disk around Earth, and over time, it coalesced to form the moon. What makes Gaia 20 Ek's situation so remarkable is that it's a real-world example of a similar event. The infrared data indicates that the material surrounding Gaia 20 Ek is freshly heated, suggesting it has been generated by a violent collision similar to those that shaped the moon and other celestial bodies. Now, as this debris cloud orbits the star, it has not settled yet. Its distribution remains uneven, and astronomers are continuing to track how the material spreads out. What makes this so exciting is that the cloud is still evolving, which means the system is far from being in a steady state. In fact, the uneven distribution of material could eventually lead to the formation of larger planetary bodies or even moons, just like the moon once formed around Earth. So, what does this discovery tell us about the bigger picture of planetary formation? This rare observation allows astronomers to study the process of planetary evolution firsthand. For years, scientists have theorized that planetary collisions play a critical role in shaping young planetary systems, but until now, much of this has been based on simulations and indirect evidence. The Gaia 20 EK system provides direct observational evidence of such a collision and its aftermath. By studying this real-time data, astronomers can now compare their theoretical models of planetary formation with what's actually happening in space. This discovery also provides crucial insights into the potential for moon formation around young planets. The debris cloud surrounding Gaia 20 EK could eventually coalesce into moons, similar to how Earth's moon formed after a massive impact. If this happens, the Gaia 20 EK system could one day have a planetary moon configuration, much like our own solar system. The implications of this go beyond just the formation of moons. Large moons play a critical role in stabilizing a planet's axial tilt, which helps moderate climate variations. They also influence ocean tides and circulation, which can have profound effects on the development of life. By observing these processes as they happen, scientists can better understand how Earth-like conditions are created and how common such environments might be in the universe. Moreover, Gaia 20 EK may not be an isolated case. The fact that this event was detected through long-term monitoring suggests that similar planetary collisions may be happening elsewhere in the universe, but we simply haven't noticed them yet. The key to finding more of these systems is continued long-term observation, and the growing number of sky surveys makes this more feasible than ever. As astronomers observe millions of stars over extended periods, they'll be able to spot similar fluctuations in brightness and identify more planetary collisions in the future. Looking ahead, the study of Gaia 20 EK provides an important stepping stone in understanding the dynamics of young planetary systems. The ongoing observation of this system and similar systems will reveal even more about how our own planet and others came to be. Could Gaia 20 EK help us unlock more secrets of how Earth-like worlds are formed? Only time will tell, but for now, it's one of the clearest windows we have into the violent and chaotic processes that shape planetary systems. So, what do you think? Do you believe we're just scratching the surface of discovering more planetary collisions? Let us know your thoughts below and make sure to hit that subscribe button to stay up to date with all the latest discoveries in space. As we continue to dive deeper into the significance of Gaia 20 EK, it's important to emphasize the scale and potential implications of this discovery. The debris cloud we are witnessing is not just a short-lived event, it's part of a broader process that shapes how planetary systems evolve. This discovery highlights the role of collisions between young planets, a key event in the development of rocky planets and moons. The collision that created the debris cloud around Gaia 20 EK could have far-reaching effects, including the formation of new planetary bodies, just like the collision that created Earth's moon. But what's particularly interesting about Gaia 20 EK is the irregular nature of the event. The debris cloud is not uniform or stable, it's still in motion, spreading out as time passes. The uneven distribution of the material around the stars suggests that the collision was violent and produced a significant amount of debris. This is crucial because it provides a direct comparison to the theoretical models of planetary formation that have been largely based on simulations and indirect evidence. For the first time, astronomers are able to observe this process in real time and gather data that will help refine their understanding of how planetary systems form and evolve. What's also significant about Gaia 20 EK is the potential for continued observations. The cloud of debris is still evolving, and astronomers are monitoring it closely to see how it changes over time. As the material begins to cool and clump together under gravity, it could eventually form moons or even larger planetary bodies. This process takes time, but it is detectable through changes in the star's brightness and the infrared emissions coming from the cloud. If Gaia 20EK follows the same pattern as other planetary systems, this debris cloud could eventually give birth to a moon, further expanding our understanding of how moons and planets are formed in other star systems. The discovery of Gaia 20EK also opens the door to a broader question. Are planetary collisions more common than we thought? Up until now, scientists have speculated that such collisions are relatively rare events in the lifespan of a planetary system. However, the data gathered from Gaia 20EK suggests that these kinds of collisions might actually be much more frequent than previously assumed. The key to this discovery lies in the long-term monitoring of stars and the detailed analysis of their brightness fluctuations. Gaia 20EK's case was not observed at the moment of impact. Instead, it was inferred from a series of gradual brightness changes over several years. This raises the possibility that other planetary collisions have already occurred, but we just haven't detected them yet. If this theory holds true, it means that astronomers may be able to find similar collisions by analyzing data from ongoing sky surveys. The data gathered from Gaia 20EK could serve as a blueprint for identifying and studying other planetary collisions that may be unfolding elsewhere in the universe. Additionally, the success of combining visible light and infrared data is a crucial step forward in planetary science. By observing both wavelengths of light, astronomers were able to differentiate between a regular dust cloud and one produced by a violent planetary collision. This technique is essential for future observations, as it will help scientists detect similar events across millions of stars in different stages of development. These discoveries are just the beginning, and as technology advances, we may uncover even more hidden cosmic events that have been right in front of us all along. The study of Gaia 20EK and its debris cloud is not just about understanding one star system, it's about learning how planetary systems, like our own, form and evolve. This rare observation provides us with a real-time look into a process that shapes rocky planets and moons. The infrared emissions, the irregular brightness dips, and the dynamics of the debris cloud all provide valuable insights into the violent and chaotic nature of planetary formation. The real impact of this discovery, however, will be felt in the future. As astronomers continue to observe Gaia 20EK, they will track how the debris cloud evolves, how it cools, and whether the material begins to form stable planetary bodies or moons. These observations will help refine our understanding of the processes that lead to the formation of rocky planets, moons, and even Earth-like environments. But this is just the tip of the iceberg. Gaia 20EK represents a window into how planetary systems are created, and it raises a bigger question. How many other star systems are undergoing similar processes? With the ongoing advancements in telescope technology and sky surveys, astronomers will likely detect more planetary collisions in the future. The more collisions we find, the better we'll be able to understand how our own planet and others came into being. As we continue to track Gaia 20EK's evolution, we are not just looking at a single star system. We're looking at a key piece of the puzzle that will help us unlock the mysteries of planetary formation and perhaps even find new Earth-like worlds in the process. Stay tuned for future updates, and don't forget to like, share, and subscribe to stay up to date with the latest discoveries in space. The universe is full of surprises, and Gaia 20EK might just be one of the most exciting ones yet.